Hi everybody, welcome to the first lesson in your flipped classroom. We will be beginning with Unit 1.1. The lesson is on input-output machines. Please make sure that you have this paper, your notes paper, in front of you so that you can follow along with the lesson and complete the notes as I do. The first thing I'd like you to notice on your handout, of course, is the area to write your name. So please make sure that you do that first, and also to write the date underneath it. So we're talking about input-output machines, and they're a way to show patterns with numbers. So this is an example of an input-output machine. So whatever number I put into the machine, it's going to be multiplied by 5, and it's going to give me a different number as my output. For example, when I input the number 6, I can think, well, 6 times 5 equals 30. So my output is 30. If I input the number 9, I'm going to think, well, 9 times 5 is 45. So if I put the number 9 into my output, multiply it by 5, I get an output of 45. We can use an input-output machine to make a pattern. Below you'll see another example of an input-output machine. This is a table of values here. And the operation for this table of values is to add 8. So when I take the input number of 1 and I add 8 to it, I get an output of 9. When I input the number 2 and I add 8 to it, I get an output of 10. So if I'm thinking about an input number of 3, 3 plus 8 is going to give me an output of 11. 4 plus 8 will give me an output of 12. 5 plus 8 will give me an output of 13. 6 plus 8 will give me an output of 14. And 7 plus 8 will give me an output of 15. And what I want you to notice here is what's happening with the pattern numbers when I look at my input and I look at my output. So this machine adds 8 to each input to get the output. The pattern rule that relates the input to the output then is to add 8 each time. When each input increases by 1, the output also increases by 1. The pattern rule for the input in this case, if I take a look at these numbers here, would be that I start at 1 and then I am adding 1 each time. If I take a look at the output and I want to think about the pattern rule for my list of output numbers in this table of values, I'm actually starting at the number 9 and I'm adding 1 each time as well. Here's another example of an input-output machine. So this one actually has 2 operations. So if I input any number into this machine, I'm going to multiply it by 2, add 6, and that will give me an output number. If I want to think about what the pattern rule is that relates this input to this output, I'm simply restating what these operations are. So in this case, the pattern rule that relates the input to the output is to multiply by 2 and add 6. So if I have a table of values down here and I'm starting with the number 2, I'm going to follow this pattern rule to help me figure out my output. So in this case, I'm taking 2 times 2 and adding 6, which gives me 4 plus 6, which then equals 10. For the number 4, I know that 4 times 2 is 8, and 8 plus 6 is 14. 6 times 2 is 12, plus 6 more, then equals 18. By now I can start to see a pattern happening from my numbers in my output table here. It looks like I'm increasing by 4 each time. So I can actually continue to increase that pattern, or I can put my numbers and follow the operations and continue the way I have been. In this case, I think I'm just going to add 4 to 18, and that gives me 22 and 26. And if I want to check to see that this is correct, well, I'll just take 10, times it by 2, which gives me 20, and then if I add 6 more, I have an answer of 26. When I want to look at the pattern rule for just the input, I'm taking a look at these numbers over here. And in this case, I'm going to be starting at 2 and I am adding each time, 2 each time. If I want to use this table of values and take a look at the pattern rule for the output, well, I'm starting at 10 and I'm adding 4 each time. So we can use tables of values to help us look for patterns in numbers. We can also draw pictures to show the relationship in a table of values. So in this table that I have here, the input increases by 1 each time. If I'm looking at this, starting at 1, I'm adding 1 each time. And the output increases by 3 each time. So in this case, I could draw a picture of this pattern. If I assume that the figure number is the input and the number of squares I'm about to draw represents the output, I can model this pattern through a diagram. So here's figure number 1, and figure number 1 has 1 square. Figure number 2 has 4 squares. Remembering, of course, that figure number represents the input and the number of squares represents the output. Figure number 3 has 7 squares. And figure number 4 has 10 squares. Lastly, figure number 5 has 13 squares. And I could continue on if I wanted to, extending this pattern. There we go, 13. So I can draw pictures, or I can determine a pattern rule by using a table of values. So in this case, this next example, I have a table of values, but I don't know what operations are occurring here. I do know that this table shows the input and output for 2 operations, as that's what's stated there. So I have to figure out what those 2 operations are so that when I put 1 into my machine, it spits out the number 1. Or if I put 2 into my machine, it spits out 5. So a way that I can do that to identify the numbers and operations in the machine, I'm going to take a look at the output. Okay, so I'm going to take a look at the patterns for the output. Sorry, that should be patterns. There we go. When the output increases by 4, each time, then the input has to be multiplied by 4. If this is an increasing pattern, then I need to think about what operations go with increasing numbers. And if I'm increasing my numbers, my options are addition or multiplication. So I'm going to start with multiplication. So in this case, it means that the first operation in my machine is to multiply by 4. The problem is when I multiply 2 times 4, I get 8. And I actually need an output of 5. So to get to 5, I have to think about how I can do that. And probably the quickest way for me to go from 8 to 5 is to subtract 3. And before I know that subtracting 3 is the second operation in the machine, I have to check all of the input numbers. So if I think 1 times 4 is 4, and 4 minus 3 equals 1, that works. Let's try 2. 2 times 4 equals 8, and 8 minus 3 equals 5. That works. I'm going to try one more just to make sure, and then I can presume that my second operation of subtracting 3 for this table of values is correct. So 3 times 4 equals 12, and 12 minus 3 equals 9, which is the third number in my output machine. So I know that the second operation is to subtract 3. So for this table of values, I need to multiply by 4 and subtract 3. So the pattern rule that relates the input to the output would be to multiply by 4 and subtract 3 each time. Now I can use this pattern rule to predict the output for any number I want to use as my input. For example, for an input of 8, I can think, well, 8 times 4 equals 32, and 32 minus 3 is 29. I can check this by extending the table as well. So up top, I left off at 17. And I know I'm adding 4 each time to my output. So if I have an input of the number 6, then 4 plus 17 should be 21. And then 21 plus 4 is 25. 25 plus 4 is 29. So when it comes to checking my table of values to see that my operations are correct, or to find any output for any given input, I can simply extend the table, or I can follow the operations and the pattern rule, and I can multiply and I can subtract to verify my answers. And that's the end of our lesson. I will challenge you now to go on to the recap and complete the questions there to see if you understand this. If you need to watch it again, please do. Thanks for listening.